All right. Mute this one. No, that's not the right button. Says it's muted. I'm confused. Let me turn the volume off. Mute. No, wrong mute. Mute. Am I still coming out of the speakers? This room is small enough that you can hear me, even you in the back corner. Back corner guy, what's your name? You're not in the back corner. Aaron? Aaron, cool. All right, I think it says we're live. Okay, so ME3820, C-term 2022. Last time I looked, it said there was 16 people in the class. How many people are here? 2, 5, 8, 10, 12, 14, 15. That's pretty close to 16. Wow. This class has a capacity for 30 people. I planned for 30 people. 16 is going to be way more fun. Because with 16, it can be more intimate and we can engage more with each other. And as you'll see as we go through the syllabus here for a minute, how far can I go? All right, if I go this far, I'm out of the frame of the camera. All right, this is pretty good. Okay, so let me switch this to this. It's not quite as fractal anymore. So as you'll see as we go through the syllabus here, this class is about participation. They say 80% of life is showing up. You've heard that? So 80% of your grade in this class is based on your participation in this class. 5% of your grade in this class is going to be based on your self-assessment of what grade you deserve. 10% will be based on your classmates' assessment of what grade you deserve, or actually your group members mostly. And 5% will be based on my opinion of Charan, with a C. Charan, okay. So if I like you, for example, you'll get all 5 of those points. And like if I don't like you, for example, you won't get any of those 5 points. So you should make me like you. When I tell a joke, you should laugh. Before I get to know everybody's name, you should shout out your name while you're laughing so that I know who it was that was laughing at my jokes, because that'll make me feel satisfied. And really, it's all about making the professor feel satisfied, right? Has anybody got a computer phone or something that they could quickly log into Canvas, click on the YouTube link, and make sure that it's got like audio and everything coming through so that it's not a waste. Actually, if you're watching from home, you could put a comment and tell us if there's audio, because it says there's somebody watching. It is working? Okay, perfect. You might want to turn it off now, otherwise you get like a delay, 2-second delay. Perfect, outstanding. Now we get 16 people. That might be everybody that's registered for the class. It's exciting. Okay, so the other thing that you're gonna learn in today's class is that I don't know yet what the class is gonna be about. I've got some ideas and I've got some plans, but what's the title of this class? Computer aided manufacturing. Is that the title, the whole word? Yeah. Has anybody read the course description? You've read the course description? Anybody else? Be proud. Stand up if you have read the course description. Yeah, at some point. Let's see who's still sitting. So Shugu is still sitting. All right, now stay standing if you read the course description within the last month. All right, you guys are standing, right? All right, what's the class about? Computer-aided manufacturing CAM software, learning how to program. What's the class about? You can sit down. Oh, what's your name though?
My name's Sean.
Sean, Charan, Shogu, Sean. S-H-S-E? Okay. So you're like, oh, that's perfect. Kid that lived across the hall from me freshman year was Sean, and it was S-E-A-N. And he had big hair. And we had him convinced that his hair was falling out. And we signed him up for the Hair Club for Men. And he would get all these mailings in his box, and it would be like, you and I both know your hair is not going to grow back. It's really funny because, you know, the guy who was going bald, and Sean still has a full head of hair, 50-something years old. What's the class about?
So I'm Sam, by the way.
Sam.
I've already touched on this stuff, but some of the things also mentioned was like using labs for delivering material, PLCs, projects.
Okay. Okay, perfect. He said his name. Was it Matt? Tim?
Begins with the same letters as mine.
Sam. I knew it was one syllable. I did remember that it was one syllable. Sam, Sean, Sharon, Hugu. What's the class about?
Well, there's one thing.
Okay. So I think we're going to talk about, you can sit down. Oh, what's your name? Alex. Sam. I hope there's not a quiz at the end of class. All right. Well, I should quiz you if you remember everybody's name at the end of class. That'd be perfect. All right. I just want to quickly flip through. So everything will be here on Canvas in the syllabus. The syllabus is just like a Google Slides thing that's shared in there. So when we need to fix it, I could actually click the link and edit the slides, so we can edit things on the slides. One of the things we're going to be editing as we go through is what each class period is going to be about. All right, so I already know what Thursday is going to be about. Thursday is what, 2 days from now? Thursday, we're going to talk about 3 to 5 axis machining and do a thorough introduction. Who has no experience using a CNC machine tool? That happened last time I taught this class. Okay, so everybody's got some experience running a CNC machine tool, so that should be good. We're gonna go through that, and let's see, what are we doing today? Today, if you go in, who doesn't have any way to access Canvas right now? Everybody has a way to access Canvas right now? So you go into Canvas and you could do some quizzes. Okay. So what I've got, if you go to assignments or quizzes or whatever, if you go to the syllabus, it actually is in there, right? Syllabus, syllabus. If you scroll down, so these are the ones that are due today. What I want to do here is gather some information from you about specifically the things you want to learn. And then we're going to pool that information together from the class, and we're going to use that to design which lectures we're going to do, when we're going to do them. And we're also going to, did I mention group work? So we're going to form into groups. 16 people. 16 is divisible by 2, by 4, and by 16. Those are my choices?
And by 8.
Oh, and 8, because of the 2, right? 2, 4, 8. So we can have 2 groups of 8. That doesn't sound like fun. We think 4 groups of 4? And then if anybody adds the class or drops the class, we'll go up or down by 1 in one of the groups. All right, that sounds good. I have capacity to do 5 groups, so I can just turn some of the groups off. That's perfect. So we're going to do 4 groups of 4 people. I'm going to assign you to your group. I'm sorry. But as we go through the quizzes here, in one of the quizzes, you're going to give me your personality type. One of the quizzes involves doing a personality exam, and then you give me the feedback from that exam, and I'm going to use the personality types to assemble the groups. I have done this once before, and it worked fantastic, which is better than the last time I did it, I could say, because last time I did it, I said, I have no idea about this, and we're going to try it. So we're going to try it again, because it was a good way to pick groups in the past. So first off, is there anybody that's ready to drop the class now? Okay. Just checking. You have that option, right? I'm going to give you all the bad stuff at the beginning. What the plan is we do the classes. Today's Monday, right? What's a Monday schedule? It's a Monday schedule. So today's Monday. So Mondays will be sort of a lecture format style where we'll do a lecture presentation on the topic that we've chosen for that week. And it'll be a bit of me talking, a bit of you discussing. Maybe we'll get into our groups to do that discussion. Maybe we'll do a group exercise where the group does some research and then reports back to the class on what they learned in that. And then the Thursdays, except for this week, the Thursdays will be the groups presenting on their progress for the project that they're working on. And as we get through the quizzes today, we're going to actually define what those projects might be. Last time I taught the class, it was a free-for-all. I let the groups pick their projects. There was mixed success on the quality of the project that was chosen. I think it was good effort on all the projects, but mixed success on the quality. And there was twice as many people in the class last time. So the groups were much bigger. So this is going to be a lot more fun. All right, so everybody get into Canvas and intro topics, how they're not in order. I would do them in the order of numbers. So do intro topics number 1, intro topics number 2, 3, 4, and 5. And some of them will take you a few seconds to complete because it asks you like 2 questions. The fifth one, I think the fifth one is the one where we ask you to go do the test. Let me preview this. Nope, not the fifth one, back one. And if you're watching from home and you can do this now, hi, watching from home, and thank you for letting me know you can hear me. If you can do the same thing, that'll be perfect. We do have one student that's going to miss some classes at the beginning of the term, but they are online, so that's perfect. All right, so we'll take a few minutes to do this. I will check on your progress here. I'll stop sharing the screen for a minute. And while you work on that, I will drink my coffee. Oh, I should play soothing music while we do this. Yep.
For the personality test, I don't see the actual like thing that you use as your example. Does that need to save results where you got the role and strategy things from?
Yeah, I think you have to give them your email address,
Okay, cool. Thanks.
and then they give you that.
Oh, I just oh. Thank you.
In the intellectually or on the software? Do you mean intellectually what's the difference, or on the software what's the difference?
I mean, like for the question on
It should give you both of those when you look at your result. It should tell you your
yeah, you can see it.
Do you think though you can go the role of what the personality code is?
Yeah.
yeah.
Okay.
But the type is like your type is more like your attitude and the way you react, and the role is the things you tend to do when you react, I think, is sort of intellectually. But I'm not the psychologist, so I don't know.
That's better.
That's how I understand it. I don't want to take the quiz. Why am I in student view? Raise your hand if you're done. One. Some other people must be done, right? Oh, there's question 5 is after that. Okay. Should have people do something to indicate they're done when they're done.
How wordy of a cover letter? I guess one is right.
So is everybody done up through 4, question 4? So the personality test? Yeah, why don't we have the question 5, work on that later. So cover letter should be a few paragraphs, right? And it should be, why you're excited about the job and what makes you good at the job. But your resume covers the information. I'm not asking you to make a resume. Because I wouldn't want to look at all of them anyway. But yeah, so why you're excited about it, what makes you excited, and what makes you good at it. All right, so let's continue on that last question, and if you could get that submitted by tonight, that would be perfect. And I think the whole class is either here or online, so I think we should have all this. So what I'm going to do is I'm going to look in detail at the answers, sort them, look at some histograms. Let me share the screen again. Present. All right, and this might be a little bit hard to read, but I'll zoom in on the stuff that's important. So I just want to quickly go through this as a group, and then we'll move on to the next questions. So I think one of the most important questions is what you really want to get out of the class and what you really don't want the class to be about. I think that we'll find that there'll be some contradictions. There'll be some people that really want something and some other people that really don't want that something. How do we solve that problem? Engineering is about problem solving, right? Raise your hand if you're one of the people that said you didn't want the class to be about math. Not to put you on the spot. Be proud. Be proud if you didn't want the class to be about math. Engineering's math. just a bunch of word problems. Cancel the units. So the class could be about poetry instead of math if you want. All right. I understand what you mean, though. You don't want to be doing a lot of linear algebra and solving inverse matrices and doing a lot of calculus, right? You want to do the engineering kind of math rather than the math kind of math. Or is there anybody that just doesn't want to add? Okay. So I'll ignore the I really don't want math answers because I don't either. But it's going to be math. It's hard to do engineering without some math. Let me see. Can I zoom this? I can zoom this with a little draggy thing, right? That's the other way. I am trying to drag it the correct way, and the mouse was just not cooperating. All right, so I've deleted the names to protect the innocent or the guilty. So this is what we do want. All right, so want to learn about some design for manufacturing, incorporating CAD and CAM, make manufacturing process more efficient. CNC experience, simple parts, so you want to do more complex machining, more complex parts, fixturing. Okay. Take steps from CAD to CAM. What software does one need to go from 3D SolidWorks design to a physical model? Create a simple part from a computer model. There was a version of this class where the first week of the class, I gave you a drawing of a part with some tolerances on it. And the group's assignment was come back in 2 weeks with 5 pieces that met the spec. And it was on you to figure out how to do it. I hesitate to do that as a first lab, but it's something that we could look at towards this. So it's because simple parts can be tricky sometimes too. So the part that we were making was a T-nut. And so if you've set up the machine tool and you've put the vices down, that's the nut that slides into the little slot. And so if you miss the tolerances, it doesn't slide into the slot. If you mess up the threading, it doesn't go, you can't put the fastener in it. I was actually amazed at how many bad parts we got back. So there's some chance we could do something like that. How to design and manufacture parts, CNC machining, CNC skills, programming toolpath, full process to making CAD to physical production. So it seems like everybody pretty much wants to do some CNC machining. Okay. And what do we not want to do? All right, somebody says I don't want to. Wait. Design for manufacturer. Okay. The person who wants to do design for manufacturer doesn't want to do CAM. Okay. That's fair. I'm thinking the people that want to do CNC machining don't want to do CAM. That seems weird. All right. Functionally useful parts. Don't want to do chemistry or mathematics. Is everybody here? Who's an ME? Who's not an ME? What's your major? And in the CS, both of you? Oh, material science. That's close enough to ME. So you have to take, how many math and science do you have to take to get a degree in ME? 6, right? Used to be 6 when I was a student here. And at least one of them has to be physics and at least one of them has to be chemistry, right? Who took more than one chemistry? Really? All right. But you were the only hand that went up, huh? Was it, which chemist, just 1 and 2? Yep, 1 and 2. Who did everything they could to avoid chemistry 2? I took geology to avoid Chem 2. And I heard that geology was going to be a really fun class, and there was a really cool field trip where you went out to Mount Tom and you hiked up and you looked at the rocks, and that the professor was really cool, and that it was an easy class to get an A in. Yeah, he was on sabbatical that term. I had somebody else who was a hard-ass geologist, and it was not an easy A or an easy science credit. Probably should have taken chemistry too, because at least it would have all been from the book. All right, remembering, all right, don't want to remember exact procedures. Yeah, so I find that the exact procedures that you need to remember, you remember them because you do them a lot. And the ones that people memorize, make you memorize for the sake of memorizing them, that's stupid. So I won't require you to memorize stuff. If we do anything like a quiz or an exam or anything like that throughout the class, it'll be open book, open notes, talk to your friends. Because engineers don't work in a vacuum. So it's about understanding that the knowledge is available and being able to access the knowledge when you need to have it. That teaches you to be an engineer. Memorizing tables and charts does not help. So I agree with that. Another one doesn't want to write G-code. Doesn't want to do endless menial programming. Okay. So endless menial programming means simple stuff over and over again, I guess. That makes sense. Don't want the class to be about math. Don't want it to be about a history of manufacturing. So when I was young and we would go out and pick up flint off the ground, we would chip it into shapes like knives and arrowheads, and then we would exchange them for meat, and that was when we started manufacturing. Back when I was young. Don't want it to be about economics and business, programming, coding, not a lot of computers. I'm not a computer science major, so I don't expect to code in my classes. So I was a mechanical engineering major. I actually did all the coursework for nuclear engineering, all the coursework for mechanical design. Then I did biomechanics for my MQP, and it said mechanical engineering on my degree because I didn't know what direction I wanted to go yet. My first engineering job was coding. And I once had the job title senior software engineer. So all engineering requires some coding, but that's okay. I understand that's not what you want to focus on. Can't think of anything you don't want the class to be about. All right, you're going to have to lead one of the teams then. All right, just quickly, I don't want to get too bogged down in this because I'm going to go through it in detail. The thing that got the most interest, all right, we got 8 here. Is there a number bigger than 8? On my survey here, the thing that got the most interest was 4 and 5 axis CNC programming. The thing that got the least interest see that I just did programming. 5.93. I could write a thing to find that number too, but he was all the way on the left. I don't think so. 5.93. Who are the 3 of you that read the course description in the last month? Did you notice that it talked about signal processing in there? Yeah, we are not going to do that in this class. That course description was written over 30 years ago. They mentioned specific programming languages in there too, I think. Yeah, we're not going to do that either. And no, go ahead. So here's the thing, though. When you hire a professor, I'm an exception to this because this is not how I got my job, but when you hire a professor, you typically hire them because they do research in some area and they have lots of research funding that they're expected to bring in or bring with them when they come to your university, because the university likes to see lots of research funding. And those professors do their research in their area, but they also get assigned to teach classes. Who's experienced this? You've all been in a class taught by somebody that did research? So what they're going to teach in the class that they're teaching is the thing that they do research about. It really doesn't matter what the course description says. It really doesn't matter what the course title is. What they want to teach is the thing that their research was about. And when this course description was written, the person who was in charge of the class, he did a lot of signal processing work in order to analyze uncertainties in machining processes. So he was doing manufacturing and machining work, but he was doing it at the sensor level, right? He was putting the sensors in the machine tools. He was reading the signals from that. So a lot of what he did was about decoding those signals. That's why it was a key factor in the course description that he got to write for the class. He doesn't work here anymore. I actually had him as a professor when I was in graduate school here. And it was a fun class, and we did a lot of signal processing, even though that wasn't what the class was supposed to be about. So, but typically somebody that does ECE would do that kind of stuff. Go ahead. Partly, and this gets into politics and thinking about how to run the class. So partly it's because ABET, so we're accredited by ABET. ABET requires us to teach certain things. And one of the ways they evaluate whether or not we teach those things is they read the course descriptions. So one of the reasons you don't just willy-nilly change course descriptions is because of that. Also, it takes the entire faculty has to vote on any course description change. So there's a process. It has to go before committees and all kinds of stuff. So it tends to be that people just, I'm not saying that if you get hired to teach a math class, you go teach geology, right? But you use a lot of geology stuff in presenting your math. So I may have overemphasized the way that works, but since that's not how I got hired, I actually got hired to be an administrator and also teach classes. I figured the class should be about what the students in the class want the class to be about and stay focused on sort of the direction of the course description. But I'm not qualified to teach you about signal processing, and I don't think you have demonstrated you didn't want to learn that. So what I'm going to do is I'll go through the responses here, and I'm going to also use that to help decide what projects we want to do in the class. Now, everybody seems focused on CNC machining, and that's cool. It's the thing I know a lot about, so that's going to be easy for me to teach. But let's take a step back now, and I can unshare the screen. I think we need that right now. Let's take a step back now and think, what is computer-aided manufacturing, right? Because that's the title of the class is computer-aided manufacturing. It's this 3 words, right? And so I want to let's form some impromptu groups. Sort of the 5 of you in that back corner there, you look like a group for now. So you 4 plus the corner, yeah. That's perfect. Be in the group. Be in the group for now. The 4 of you, the 5 of you be a group, right? That's 5. 1, 2, 3, 4, 5. Yep, 5 of you be a group, and this corner can be a group also. All right. So in your group, take 5 minutes. Prepare 1 slide. So a 1-page definition that has an example, sort of like a mini poster or a 1-pager. Create 1 slide that defines computer-aided manufacturing and what it encompasses. Okay, so 5 minutes. Watching from home, I guess do this on your own instead of in the group. We'll figure out how to get you. Andrew will figure out how to get you to participate in the group activities from home, probably with text or something like that as we do the future classes. But come up with a one pager that defines computer-aided manufacturing. Feel free to violate copyright by stealing pictures off the internet if you want to, because we're not going to share these too publicly. I think it's fair use if you steal a picture for this.
No, it's fine.
We're going to give it back when we're done.
Exactly.
That's also what I'm asking.
I mean, there's some good manufacturing process needed.
So that affects like essentially for you. That doesn't affect you yourself, so for me. And then for me, also relate on that would give me something to write about that.
So either make it a PowerPoint or a Google Slides thing. And I just made a little assignment here. It's called Temp Assignment Class 1. And one person in the group just upload whatever slide you create so that we can put them on the screen. I'll look it up. Doesn't count towards grading, but it's a way to get the thing to me.
CNC allows you to design using CAD and plan out a set of instructions for the machine to make that part, like maybe higher tolerance. Tolerances, repeatability. I guess kind of an aspect of that, like right, it's like there are also parts that only it's like you can make pretty much any 2.5 part, but like
Yeah.
12. Okay. Like if you were perfectly precise and you turn the two dials at the same time, yeah, you
said
could
the actual part.
And so from idea to 3D, they're all programming.
It's like, yeah, you go from idea, model, program, and from programming. Yeah. Yeah.
So we get about 2 minutes left. Who needs more time? We'll do, all right, we'll add a little bit. Just let me know when you guys are done.
You better be here. It's gonna be like, this is This is what you look like when you're planning. Ways being computer aided. I would say yes. Yeah. That's like, yeah, I think that's simple. I guess I'm just assuming that's a good answer. So I've done, I've manufactured things I've drawn. That is the same CNC standard. I've never actually thought about it. I've just used it. It's an alien here, isn't it? Okay.
So when you've got your slide made, go ahead and go to Canvas and just upload it in this assignment here. I added it to today's list.
So I gotta. Is it okay if it's a Google slide instead of?
Yes, perfect. You can either put the link to it. Yeah. We should probably publish it as opposed to sharing it. It's probably easier. So I got one. Is that the guy from Frozen in the sauna lodge?
I don't know. Well, we were going.
It totally looks like the guy from the sauna lodge in Frozen, though.
I don't think it's in prison.
Well, I saw it many times because I had little daughters when it came out. I think within the first month that it was on Netflix or whatever, my daughter had watched it 42 times. And so just remember, you're not being graded on this. It's just a start discussion. Well, I suppose you are being graded. I'm assessing you. Grading on whether or not you're participating. Except I don't remember most of the names, so you're going to be out of luck. I see you every day, several times a day. I can't forget your name. Sean, Sam.
What was the name of the temp class?
Temp class 1? Yeah. Should be the last one that's due today. Now there's 2. So in Canvas, if you look at the syllabus page, the last assignment due today should be temp class 1. All right, and I would like one person from each group, one at a time, I suppose. All right, this is your group, right? Yeah. Select one person to come up and present what is computer-aided manufacturing using your one slide. Let me see if this is turned on. Oh, it was turned on. Let me turn it back on. Turning on, turning on. Unmute. Hello, hello. Yep, that's on. All right, speaking to the microphone. And that'll work. Yeah.
Okay, cool.
And if you're over here, you'll sort of be on the camera view too.
Yep, sounds good. All right, so just kind of a basic overview for what we talked about. So we said, just as a broad definition, that computer-aided manufacturing is incorporating computerized tools into your manufacturing processes. So some of those things that we talked about, like at the basic level, would be that if you model your part in CAM in some way, or in CAD before you do anything, and even if you made it on a manual machine with no other digital assistance, in a way that is somewhat a computerized process. But maybe a more like specific example would be, you have your part and you have a DRO on your manual machine. So there is a computer in that DRO, and that is giving some type of computerized feedback in your manufacturing process. Maybe more specific, and I have an image here on the left of that. Maybe a more specific example that is kind of more in line with what we're talking about is CNC manufacturing. So CNC allows you to take your design, ideally a digitally designed part in CAD. You are planning out a set of instructions for that machine to make the part. So we've talked about CAM and G-code a little bit, but you can use that to potentially meet higher tolerances or repeatability in the parts you're making. And then the other specific example that we talked about is, in some ways, you're kind of automating that process, or there's certain features that are not realistic to make manually. So an example would be if you want to cut out a consistent curve or weird shaped thing, it's a lot harder to move the 2 dials on a mill. And all these, I guess, are talking about mill machining to make a odd shaped curve versus a computer that at a certain level of precision, it's going to plan that out and figure out what path you're going to do that with. And then it gets more complicated, the more axes that you add to your manual machine to replace the machine. Cool.
Perfect.
Thanks.
Does anybody know what the manufacturing problem was that caused them to invent the computer controlled machine tool? It was in the 1940s. It's the history part of the class. Anybody know what the problem they were trying to solve? So they're trying to make airfoils for helicopter blades, helicopter wings. Because out at the tips, they're pretty much right at the edge of supersonic when they spin around. And that causes hard things to do with airfoils. They needed these complex shapes. They created CNC machines so that they could manufacture those. Somebody from the group in the back, come on up and present your slide. Which one is it? I just have to refresh. Austin. Looks cool. All right. Just speak near that. It'll pick it up.
So ours, we had a little bit of time setting up, so we didn't have that much time. But ours was basically, we decided to specify the definition is it converts digital instructions into a physical object, and we decided to specify as opposed to just converting digital signals into like instructions, because that would include like robot arms and stuff that aren't necessarily like related to manufacturing. And they talked a lot about CNC machines, but like a lot of things can be computer controlled to make an object, like 3D printing and laser cutting. So we gave some examples there.
Perfect. All right. And last group. You've got the system figured out? And this one is yours. You had like a cover slide for your cover slide. I like it.
So we said computer-aided manufacturing was using computers/software to create and automate an efficient process for machining and manufacturing parts, which I think kind of like incorporates the first two. So it has using computers/software. So we have an example of CAD here. So you have your part and then the tooling. So you're creating a CAM, computer-aided machining. So we kind of separated computer-aided machining, which is what make the CAD, which is the actual G code, and the manufacturing, because we thought the CAM would be part of the CAM. An example is kind of, you have the production assembly. So you have the multiple parts all working together with computers and everything. And I don't really know what more else to add.
Perfect. Andrew, I'm not going to put you on the spot from home to explain your slide, but I'll go ahead and put it up there. Fabricating quality parts through use of software and computer-operated machinery to automate the manufacturing process. Okay, so we should vote. Who had the best slide/presentation? Maybe we should say who had the best slide. So, first group, was that the best slide? All right, let's see. Can we get all three of them up there at once? Probably not. So, first one was Sam. Group one. So now we're voting on slide quality. So Sam, Andrew, Jose, but this is the slide you looked at, right? And Austin. So 1, 2, 3, or 4. You want to do this again? You guys like, all right, so stand up if you like 4. All right, wait. All right, so you can stay standing if you like 4. How do I separate people? Right hand up if you like 3. Right hand up if you like 3. You gotta keep it up. You gotta keep it up. Left hand up if you like 2. You were one. And I don't know, nothing if you like the last one, right? Okay, that separates us all. So, okay, one, you had one, 2, 3, 4, 5, 6, 7, and one. It's about even between 3 and 1 and 2, right? Okay, good. How about best definition? What was the best definition? What was the common thread in the definitions? What was the common thread in all the definitions of computer-aided manufacturing? Well, right, so everybody touched on machining, right? Is that the first thing that comes to mind when you think of computer-aided manufacturing? Is CNC machining and CAD and CAM. And we certainly called it computer-aided manufacturing before CAM was a big thing. When all we had was CAD, because when we started getting CAD, when I took, who said the ES1310? Most of you have taken ES1310. So in ES1310, what did you do? You learned how to use CAD software, right? And maybe you learned when you should use certain parts of the CAD software to do different things. When I took ES1310, I learned how to roll my pencil to keep the line thickness the same all the way across. Because line thickness tells you stuff in drawings, right? You do those drawings, the thicker lines and thinner lines mean different things. So we had to learn how to roll our pencil to make sure the line thickness stayed the same. It was about 50% of the class. The other 50% of the class was using this new CAD software that the school had just gotten installed, maybe like the year before. And so it was same classroom, like HL230 over there. It wasn't HL230 because that part of the building didn't exist then. But it was on that floor. And I remember doing my final project and sitting in there, and it was the day before it was due, and the lights flickered. And I clicked Control S, Control S, Control S, Control S, and the power went off to all the computers. And I was like the only person that saved everything as the power was going off. So, I don't know, genius. All right, so we all thought about computer-aided manufacturing as being CNC machining. Some of you added robots. You guys went deep in the idea that just the fact that you did the programming or the drawings was computer-aided manufacturing. That's definitely all true. But it's 3 words, right? So can I make the screen go up real quick? Screen go up. Room control. Screen up. And projector mute. And remove screen share. All right, and I'm going to go to solo layout. This way, we're capturing this on the thing. You know what I didn't test before we got here? Do any of these whiteboard markers actually make marks on whiteboards? This is going to be... Oh, we got one. All right, perfect. Computer-aided manufacturing. What's computer? Right? We've got some intuitive understanding of what's a computer, right? But it's a device. It typically electronic. Doesn't have to be. They make mechanical computers, right? It's a device that helps us do math. Is that pretty much what a computer is? So a device that helps us do math. Now, we've tricked computers into doing other things like poetry. And I was actually using an AI thing to write. I have a thing for haikus. So I have been using this AI thing to write haikus. And I don't think the intelligence level is there yet, but maybe I'm just using the wrong AI. Because I always think that I could come up with a better haiku than the computer has come up with, but at least it understands what a haiku is. All right, so we've tricked these math devices, TH, into doing stuff beyond math, but in reality, a computer is a device that helps us do math. I guess that makes an abacus a computer, huh? Never really thought that through, but I guess by my definition, that makes an abacus or a slide rule a computer. I'll go with that. Oh, that's definitely a computer by this definition.
Add electronic to the definition.
I don't think you should add electronic. I'm not sure.
But I don't think it adds to the computer.
You have an analog.
Well, but they could be still electronic. But all right, so there's some debate. Electronic, mechanical. Is anybody really good at spelling in the class? Anybody? All right, you sort of raised your hand. You do the red squigglies when I really screw up. Because that's the only way I learn how to spell, is when it's a red squiggly. All right, so a computer is a device that helps us do math. Typically, it's electronic. The ones that we're talking about in computer-aided manufacturing for the purpose of this class are almost all going to be digital, in fact. But they could be analog, and there's different things. All right, so perfect. Device that helps us do math. Computer-aided. I mean, I think we're getting into philosophy of computers now, but it doesn't set up the problem for you typically. Right, so it's helping you do the math. It's doing the math for you, helping you do the math. I think we're saying the same thing, but the computer itself is just a bunch of switches. And they're either on or off if it's a digital computer. Right. So helps you does the math for you. I think, yeah. So at this level of the definition, we're probably nitpicking on exactly what it is, because I could spin it that both of those things mean the same thing. I don't know if I could convince you that both of them mean the same thing. But you should believe, because I'm the one that does the grading. All right. But anyway, so it helps us do math. It's a device that helps us do math, and we're using it to help us, right? Aided means help, right? So we're redundantly helping. So help squared. Or is it just to help? I don't know. Help. Manufacturing. And so for the majority of our class discussion or distinctions here, we called manufacturing machining. Your group added a robot. At least you had a robot in the picture. And one of the groups specifically excluded robots.
We were talking about saying computer-aided manufacturing definition was converting digital instructions into some as physical action.
Okay.
But I don't believe that programming a robot to move its arm is computer-aided manufacturing, which by the definition is included.
All right. So I think what we're debating then is what defines manufacturing, right? Okay, so all right, so we have a test definition for manufacturing. What's your name again? Constantine. Constantine says that manufacturing is making something. So manufacturing is making something. I don't know. I used to manufacture all kinds of stories when I did stuff wrong as a kid to get away with stuff. I'm kidding. All right. So making something, is that enough to make it manufacturing? Or, I mean, does anybody disagree that, does anybody say that manufacturing does not involve making things? So we all agree. Okay. So we all agree that manufacturing is making something. Is that all that manufacturing is? So I say that manufacturing is making something with the intent to sell. And you could use all the same processes to simply make stuff, right? What makes it manufacturing is this business aspect of it, that you're doing it for a purpose. Now, you may not be selling it. You may be trading it. You may be offering it as a gift for free. But it's, so before I said with the intent to sell it, I used to say making something someone else wants. Right. So making something for someone else could also be an equivalent definition of manufacturing. So there's way more ways to manufacture stuff than CNC machining. Is that correct? So manufacturing includes a lot of different processes. So who's ever drunk a beer? Most of the hands go up. You should like half hide your hand if you're not over 21, because, well, no, you could have been in a different country. Could have been legal when and where you did it. Who's ever been to a beer bottling facility? Was it cool? Did it smell like stale beer? Yeah. And so, but who's ever seen a bottling facility on TV or on the internet or something? Canning facility, same thing. Same idea, right? So are they using computer-aided manufacturing there? Because there is a, I shouldn't put people on the spot, but is anybody going to get offended if I swear occasionally? Use naughty words? I remember having this discussion with my daughter when she was in kindergarten. We were driving back from school and like explaining, well, you know, words are just words, right? Some words make other people offended and bother them. We shouldn't use those words in front of those people, right? And that's what makes a word a bad word. So I was just going to say that there are a shit ton of computers in a facility like that. Then I realized maybe I shouldn't say that. Is that one of the words you can't say on TV, right? It is one of the 7 words you can't say on TV. It's all kinds of words that they do say on TV that I would think should be up there. Words that I wouldn't use here. But all right, so there's more than one manufacturing process that could be aided by a computer. Could we agree to that? And I disagree with your robot expulsion because of that.
We could be like turning on an oven.
I meant like
Anything that is related to manufacturing.
Well, turning on the oven is definitely related to manufacturing if you're making fish sticks.
it could be manufacturing, but
Or-
it's not necessarily manufacturing. That's what I meant.
Or okay, so not all. I agree. Not all robots do manufacturing. 100%, and not all fish sticks are manufactured. They could also be cooked with love in a kitchen. But the ones you buy at the grocery store, they were manufactured. They who's used the bandsaw in Washburn, the big vertical bandsaw, cut something, push it through. Same exact model in the Viking seafood factory, and it's a factory. That's what they use to cut up those fish sticks. Same exact. I assume they cleaned it after they took it out of the machine shop where it was used. But it was fun. They get that frozen fish. It's much easier to cut fish with a bandsaw when it's frozen. And they cut their slices, they batter them, and then this chain conveyor, put them on up at one end, brings them down through the hot oil, comes out the other side and into a flash freeze to freeze them. So they're manufacturing fish sticks there. They are using computers. So what happens if the chain goes too slow? They get burned, right? Chain goes too fast, you get food poisoning. Probably. I mean, you're supposed to put those in the oven and cook them anyway, right? Yeah. So computer-aided manufacturing is beyond just CNC machining. I could see from our survey that most of us want to spend a lot of time in this class talking about CNC machining. And so we'll devote the majority of the class to talking about CNC machining-like topics. But, and there's at least one person who doesn't want to talk about the business part of manufacturing. And the class won't be devoted to that, but we should understand that it's part of it. Because if you're not thinking about the business part of manufacturing a little bit in the back of your mind, you'll end up making stuff that nobody wants, and it'll be fun for a little while until you can't afford to pay the light bill. So we'll get into that. What else? Computer-aided manufacturing. I'll save this question for a later class. We're done with the programmed activity for today. Does anybody have anything they want to talk about today? Life, liberty, the pursuit of happiness, zombie apocalypse.
I have some course-specific questions that I don't know if you might cover these.
Yeah, go ahead.
For like the group work, project work and stuff, there's not any actual like class time or that is dedicated specifically to being in the lab and being in the shop, right? That is like self-coordinated essentially.
Yeah, so we have 4 hours a week in the classroom, and the rest of the class time is ad hoc between yourselves. We have our TA in the back. Stand up. He's not listening. Stand up and introduce yourself. Come up and introduce yourself to the class. But you're a part-time TA for the class, right? And so, in 10 hours a week. And do you have some time right after class? So we'll talk later. But introduce yourself to the class and we'll put in the syllabus how to get in touch with you.
Hello everyone, my name is Tara.
I should make you come up here and use the microphone, since not everybody is here.
Hello everyone, my name is Tara, and I'm in the material science. And I will send my email to you on the canvas.
Yeah, we'll add it to the syllabus, so it'll be right there.
Oh, okay. Nice to meet you. Hope to have a good grade.
Where's your office?
Washburn, grade 1.
331?
Yeah.
Okay. All right, we'll put that in the syllabus too. And so as we get to the machining part of doing some work in the labs, we'll have to figure that out on an ad hoc basis also. How much experience do you have CNC machining? So we have to work that out on an ad hoc basis as we do this, but I think we can figure it all out. Was that the only question you had?
I had another one. So maybe I missed this in the syllabus, but like specifically like software-wise, so like I'm assuming we're doing a project to go make something. So like as far as like a CAD package, CAM software, are there specific ones that you're familiar with, or you prefer that we are ready to use because it would be like what you're familiar with, or is that really?
So I would no longer say that I'm familiar with any CAD software. I mean, I understand what all CAD software does, and I have recently successfully opened some files and like rotated the part around to look at different sides of it, but I don't think that's really familiar with the software. And I'm extremely familiar with using Esprit for CAM software. We do not have a hard and fixed rule on what CAM software somebody wants to use. There's more CAM packages that are available to you. And there's different people on campus who can help with different things. So we're going to utilize that. One of the things, and I probably said this before, but engineering is about understanding the question. Right? Well, it's math, right? Just a bunch of word problems. It's understanding what the question is, figuring out what form the answer must take, and then finding someone that already knows the answer, right? And asking them the right question. Because if you do that, you speed up a lot of it. When I went to graduate school, we had this saying that a few years in the laboratory can save you a few days in the library. So you should do the days first, right? And now it's like a few minutes on Google. And you might have to eventually go to the library, but only after you've figured out what you're looking for on Google. And so, yeah, we're going to figure all that out, and it'll be somewhat up to the project groups probably on what they want to do, so that we can go out and solve problems. Anything else? So the typical course on Monday will be me talking something, and we'll do some activities like we did today. Not so much on the Canvas quizzes, because those take time and effort for me to prepare in advance, and I'm done with that. Oh, I got a TA though. He can prepare Canvas quizzes in advance. Maybe we'll get there. But some interactive discussions. I really want this to be a lively discussion-based class. That's way more fun for me. On Thursdays, I leave this class and immediately go teach another class. And so because of that, on Thursdays, I have dedicated that time to be for the groups, to talk to each other and to talk to me. So not this Thursday. This Thursday is going to be me giving a lecture on intro to 3 to 5 axis. I think it was, or maybe 2 to 5, whatever I said on there. We're going to talk about CNC machining as a thing this Thursday. And then after that, it's going to be based on the results of the quizzes, what we talk about week after week. And we'll go through that on Thursday again. And on the other Thursdays, you will talk about what you've been working on in your groups. Some weeks we may have all the groups talk. Some weeks we may only have a couple of the groups talk. It's going to really depend on how the projects light up. And, so the way that 80% participation thing gets graded, that's important to you, right? It's 80% important to you. Let me tell you how the 5% of my perception of your effort gets graded. You've all got 5 points now. And you would have to do something to make me want to remove points for you to lose points. I guess the thing would be to never show up, to never talk, to never interact, and to have not participated in the participation part, because I like the participation part. The way you get graded for your 80% participation is there's a group of quizzes called participation quizzes. You get graded on your completion of the quiz, and there's each of the evaluation quizzes has 2 essay questions. So today's essay questions, other than leaving it blank, you couldn't lose points for it, right? Because today's essay questions are your opinions. But for the when you're evaluating the group's presentations and the other things that happen each week, you're evaluated on the quality of your question or the quality of your comment, not just whether or not you made a question. So, if your comment is, great work, well, all right, you get some credit for answering the question. But in what way was it great work? Would be a better answer, right? Great work because you all seem to know what you were talking about, and you gave a really great definition of how to import models into HSM Works, because your group decided to use HSM Works, and one of the things you struggled with was how to import models, so you were presenting on how to import models into HSM Works. Can't imagine it's that hard. It's got to be like file import, but I don't know, maybe it's hard. I did once teach a class teaching CAM software to a group of people, and I had never used the CAM software before because I didn't own a copy of the CAM software. But they hired me as a consultant to teach their people that software. Here's the thing I know. All CAM software has the same objectives. It's the same steps that you do no matter what the CAM software is. And so one of the things we're going to talk about on Thursday is what are all those steps that you have to understand regardless of the software. It's the same process. And so I stood behind them. I said, well, what's the first thing we want to do? And they said, well, we got to, import our model. I said, all right, so how do you think you import the model? And so we went file, import, and say, all right, that's perfect. All right. And so while they were doing that, I was writing it down because I was also making an instruction manual for their staff to use after I left. And as we went through a week like that, they learned how to use the CAM software. I wrote an instruction manual for how to use the CAM software. They didn't know I had never opened up the software before that day because I understood CAM software. I didn't have to understand that particular interface. I did try to open the software. I couldn't get it to install on my laptop. And I didn't try early enough. I was on the airplane on the way to the place when I tried to install it. So I understand just-in-time manufacturing. I understand getting stuff done just at the deadline. Presentations usually look better if they're earlier than the deadline. And if it looks like you've seen the slides before you're standing in front of them. Anything else? All right. I am going to stop the live broadcast.